All right, lesson 2-6, special functions. By the end of this lesson, we should be able to graph piecewise functions, step functions, and absolute value functions. So to start with, a piecewise defined function is a function written using two or more expressions. Okay? So on the graph, an open circle will indicate a point that is not included, and a closed circle will indicate the point that is included. Now, before we get into graphing piecewise defined functions, we're just going to go back and review how to graph linear functions, and then we'll work up to the piecewise functions. Okay. So to start with, we're just going to graph a linear function. So we have f of x equals x minus 2. So to graph this function, we go down to -2 on the y-intercept and plot our point. And then we have a slope of 1, so we go up 1, over 1, and if we want, we can do it again so that there's 3 points. But remember, when we're graphing linear equations, we only need 2. And then when I'm looking at this, if we practice domain and range, the domain is all real numbers, and the range is all real numbers, because it's extending in both directions forever without any breaks in the graph. So the next one, if we look at it, so this is like saying x plus 0, so that means our y-intercept is 0. And then we have a slope of 1 again, so we're going up 1 over 1, up 1 over 1, and then just connecting that into a straight line. So a domain is going to be all reals, and the range will also be all reals. So again, it's going in both directions forever without any breaks. All right, our next one, we have h of x equals 3. So since we have only a number without a variable, that means that when we graph this, we should graph a horizontal line. So I'm going to go up to 3 on my y-axis. So 1, 2, 3, and I'm going to put my first point. And this means that 3 has to be our y value no matter where we're at on this function. So I can pick any x that I want. So let's say I just pick 2. That means my y value still has to be 3. So we're going to get this horizontal line. So when we're looking at this, the domain, since it's going left and right forever without a break, is going to be all real numbers. And the range, since it doesn't go up or down, it's just going to be a number. And that number is going to be wherever it's crossing that y-axis. So in this case, it's going to be 3. So since we're listing a number, we need to use our curly bracket. And then we would just write that 3 inside the curly brackets for the range. Now if we continue, we're back to graphing f of x equals x minus 2 if x is greater than 1. So this one, we have this restriction on it. So this is telling us that when we graph, we are only allowed to graph that line for x values bigger than 1. So if I go back up to this graph, it's basically telling us that we're going to go to 1 on the x-axis, and we're going to cut the graph off, and we're only going to see this part of our line. So the way that we're going to do this for this problem is we're going to do a t-chart to help us get started. And when we do this t-chart, we want to pick endpoints. So this restriction is giving us our endpoint. So I'm going to choose 1 for my x. And then we just substitute it in here. So we're doing 1 minus 2. So if we do 1 minus 2, that will give us -1. And then I need to choose one more x value that is bigger than 1. So I'm going to choose 2. So if I choose 2, 2 minus 2 is 0. So now I have enough points to finish my graph. So I'm going to start with this one. So again, this is going to be our endpoint. So endpoint. And then we need an open circle because we don't have a bar underneath. So we need it to be bigger than 1. So over 1 and then down 1. And I'm going to draw an open circle there. And then my next point is at 2, 0. So 1, 2, and then we're going to put this one. So wherever you draw your second point is the direction that our graph is going to go. So I'm going to connect these two in a straight line going this way with an arrow. So basically, we're going to end up drawing a ray if we have this restriction. Now again, for practice, if we do the domain for this one, so it's only going to the right, so that means my domain has to be everything bigger than 1. So if I write that in inequality, we would say x has to be bigger than 1, so it's matching this one. And then if we switch to interval notation, we would have a parenthesis with 1, and then up to positive infinity. And then our range, so our graph is only going up. So I want to find my smallest y value, so that's going to be at this point, so this negative 1. And I'm going to need everything bigger than that. So if we start as an inequality, we would need y greater than or equal to negative 1. And then in interval notation, we would say negative 1 with a bracket, or with a parenthesis. Oops, so this shouldn't have a bar underneath it, because it's an open circle. So parenthesis here, and then up to positive infinity. All right, let's try another one like that. So here we have g of x equals x if x is less than or equal to 4. So again, we're going to have this restriction on it. So if we go back and look at our previous graph, since we already graphed this point, this is asking us to go to 4 on the x's. So 1, 2, 3, 4. And we're going to cut our graph off. And this time, since it's less than, we need everything on the left side. So this is what our graph is going to look like if we cut that point off. So again, to start graphing, if we didn't know what it looked like, we're going to do our t-chart again. So the first x that we pick is always whatever the restriction they give us. So we're going to start with 4. And then if we substitute 4 in for x, that would just give us 4 for the y value. So again, this is going to be our endpoint. And we want a closed circle this time when we graph it because of that line underneath. And then now we're going to choose our second x value. So since we want x's smaller than 4, we want to pick like 3 or 2 or anything smaller than 4. So we're not allowed to pick x's bigger than 4. So I'm going to choose 3, and then again we're just substituting into this spot. So if we substitute 3 in for x, we would have 3 for y. All right, so now we're going to graph. So 1, 2, 3, 4, 1, 2, 3, 4, closed circle this time. And then our next point is at 3, 3. And your second point should always be a closed circle. And then we're going to draw an arrow connecting them. So now, if we do domain, so again, it's going to be the same as this restriction. So x is less than or equal to 4. So if we switch to interval notation, we need all the x's between negative infinity and positive 4 with a bracket. And then range, so our y values are only going down, so it's going to be y less than or equal to. And then we need the y value of our highest point, so that's going to be right here at 4. And then again, if we switch to interval notation, it's going to look the same. So we need all the y values between negative infinity and positive 4 with a bracket. All right, one more like this one. So here we have h of x equals 3. If it's between, so if we have two inequalities here like this means in between negative 2 and positive 4. Now again, we've already graphed this one, so that was our third problem. So I'm going to go back up here. So we're cutting off our graph at negative 2, and 1, 2, 3, 4, so right here. So that means that when we graph this, we're actually going to be graphing just a segment, and we're going to have 2 endpoints. So when we choose our x's, we're just going to choose those x's as the endpoints. Okay, so x and y. So we're going to choose negative 2 for the first x, and we're just substituting that in. So since there's no x to substitute it in for, we would just have 3 for the y value. And then now we're going to choose 4, so that other endpoint. And then again, if we substitute it in, if there's not an x there, we can't replace anything. So that means that we're just left with 3. So now we're going to plot these points. So the first one has to be an open circle. So 1, 2, 1, 2, 3 with an open circle. Second one, we're going to have a closed circle because of that bar underneath. So 1, 2, 3, 4, 1, 2, 3, closed circle. And then we just connect these together into a segment. So again, if we're thinking about domain, okay, domain is our x value, so we can only have x's in between these 2 points right here, and that's already listed for us. So -2 less than x less than or equal to 4. So if we switch to interval notation, this would be a parenthesis -2 up to +4 with a bracket. And then our range, so since it doesn't go up and down at all, our y value is 3 for all of these. So I'm just going to list it in that curly bracket, 3.